Good day, everyone. We will be discussing Bernoulli's equation. Bernoulli's equation is a special form of nonlinear first-order ordinary differential equation that can be linearized using a specific substitution. So, okay, nonlinear ni siya, but the form closely resembles those of linear differential equations. Okay, so it is of the form y prime plus p of x y equals q of x y raised to n, where n is not equal to 0 or 1. So, what if equal to 0 or 1 ang y? So, those are other cases na po. Okay, let's derive the simplified formula based on the general form. So we can just plug and play, if we have a simplified formula. Okay, so this is the general form. First, we should divide both sides by y raised to n. The right side will become q of x, while the left side will become y raised to negative n, y prime plus p of x, y raised to 1 minus n. Then we proceed with the substitution of v equals y raised to 1 minus n. So since we are replacing y, we should also replace y prime. So let's find the differential of that substitution. We have v prime equals 1 minus n times y raised to negative n y prime. Rearranging the terms, we have v prime over 1 minus n equals y raised to negative n y prime. Since we have done the preparatory work, let's substitute those values into the differential equation. So y raised to negative n y prime will be replaced by v prime over 1 minus n. And y raised to 1 minus n will be replaced by v. Okay, but we are not finished yet, since a linear form necessitates that the first derivative must have no coefficients. So we multiply both sides by 1 minus n. That will leave our v prime with no coefficients, and the coefficient of v will become 1 minus n p of x, and the right side will become 1 minus n q of x. So now our nonlinear equation of the variable y has become a linear equation of the variable v with an integrating factor of e raised to integral of 1 minus n times p of x dx. Following the pattern for linear DE, we get the simplified equation for v, that is, v times integrating factor equals integral of 1 minus n q of x times the integrating factor dx. Of course, do recall that our original variable is y, so we still have to back substitute. The final simplified formula is now y raised to 1 minus n times the integrating factor equals the integral of 1 minus n q of x times the integrating factor dx, where the integrating factor is e raised to the integral of 1 minus n p of x dx. Sir, do we have to memorize the derivation? No. You only have to memorize the boxed formulas. So how do we solve a problem using these equations? Let's start with an example. So 2xy y prime plus 3x squared minus y squared equals 0. So first, we have to rearrange the equation such that the first term is y prime, the second term is y, while the right side is a function of x. Now, the first derivative must have no coefficients, so we divide both sides by 2xy. That leaves us with y prime minus 1 over 2x. Y equals negative 3 over 2x times y raised to negative 1. So as you can see, we have made a, the equation into a Bernoulli equation, where p of x is negative 1 over 2x, q of x is negative 3 over 2x, and our n is negative 1. Okay, remember the form q of x multiplied by y raised to n. As you can see from the equation, n is negative 1. So what did we do? First, we rearrange the form into the Bernoulli equation. Then we determine which is p of x, q of x, and n. So that's all the information we need. Next, we have to find the integrating factor. So we substitute n and p of x. So we have e raised to integral of 1 minus negative 1, that is 2, multiplied by negative 1 over 2x. So that negative we can extract out of the integral. X is dx. Okay, so we get e raised to negative integral of 2 times 1 over 2x dx. As you can see, the 2 will be cancelled, leaving us with e raised to negative the integral of 1 of x dx, which will become ln of x. So now, the negative coefficient, we can use the laws of logarithms to turn it into an exponent of the x. So we get e raised to ln of x raised to negative 1, which in turn will become x raised to negative 1. That is our integrating factor. So now that we have the integrating factor, we can now plug it in into our shortened formula. So just plug in the values for n, the integrating factor, and the q of x. So we get y raised to 1 minus negative 1, that will become y squared, times the integrating factor x raised to negative 1 equals the integral of 1 minus negative 1, that will become 2, multiplied by negative 3 over 2 times x raised to negative 1. Okay, so the right side will become 2 times negative 3 over 2. The x and the x raised to negative 1, they will cancel out, leaving us with just 1. Then we cancel the 2 in the right side, which will leave us with negative 3 dx. We can factor out the negative out of the integral. Then we evaluate the integral, that will become negative 3x plus c. Okay. Then to simplify, actually this already qualifies as a valid answer, but we can simplify it further. Okay. We multiply both sides by x raised to negative 1 to get rid of the negative exponents. Okay. Then the left side will become y squared. The right side will become negative 3x squared plus cx. So sometimes it's valid to isolate the constant. Some answers isolate the y, the dependent variable, while some answers isolate the c. So in this case, let's isolate the c. Okay, so let's move negative 3x squared to the left side. So we will have 3x squared plus y squared equals cx. Then we divide both sides by x, leaving us with 3x squared plus y squared all over x is equal to c. That is our final answer. Of course, there's another way of solving this problem. If you have the time, try to use the method for exact BE and see what happens. So if you use the formula right, you should have the same answer. Try it by yourself. That would be all. Thank you for listening. Bye.